What's up, scholars? Today we're talking about using transversal angle pairs to justify parallel lines. All right, so let's remind ourselves what our transversal angle pairs are. First, so I want you to draw two lines. Do not make them look parallel, though. Don't make these lines look parallel. So we've got two lines, okay? And then we've got a transversal, trans meaning across. So our transversal, let's call it line T, is going to go all the way across those two lines. And then let's number our angles here. Let's say 1, 2, 3, 4, 5, 6, 7, 8. All right. So let's talk about the transversal angle pairs that we had previously. It's always good to keep these fresh in our brain cells if we want to extend this into using them to justify that lines are parallel. In this example, they're not parallel though. So we're just talking about what the names are of the transversal angle pairs. So we've got corresponding angles. Corresponding angles, right? That was one of our transversal angle pairs. Those were the angles that are in the same position in each of these groups of 4. So the top left position of each group of 4, angle 1 and angle 5, those are corresponding angles. Angle 1, angle 5. We've got the top rights, 2 and 6, angle 2, angle 6. The bottom rights, 3 and 7, and 4 and 8. All right, cool. We had alternate interior angles. Alternate interior angles, which were alternate being opposite sides of the transversal, and interior being inside the two lines. So opposite sides of this transversal T, and interior are going to be angles 3 and 5. Those are alternate interior. And 2 and 8. And angle, I forgot my angle symbol. There we go. Angle 8. We also have alternate exterior angles. Alternate exterior angles. Those are opposite sides of the transversal and on the outside of these two lines. So opposite sides of the transversal, outside of the two lines, going to be angles 1 and 7. Those are alternate exterior. And 4 and 6. All right. And last but not least, we had same side interior. So same side of the transversal. Let me write that down. Same side interior angles. All right. Same side being same side of the transversal, and interior being inside these lines. So same side interiors are 3 and 8. Angle 8. And 2 and 5. Okay. So I just made up these angle numbers at the very beginning, right? So they won't always be the same thing. But the important part here is that corresponding angles are in the same position in their group of 4. So the top lefts, top rights, bottom lefts, whatever those numbers end up being, those are corresponding angles. Alternate exterior, we're 4 and 6 and 1 and 7, alternate sides of the transversal exterior to the two lines. Alternate interior, opposite sides of the transversal, but inside the two lines, 3 and 5, 2 and 8. And same side interior, we're 3 and 8, and 2 and 5. Now, special things are going to happen with these angle pairs when the lines are parallel. And let's see what happens here. All right, so I have made some parallel lines here. And I chopped them with a transversal, and we're going to measure some of the angles of these angle pairs that we just talked about and see what happens when these lines are parallel. All right, let's measure some corresponding angles, angles that are in the same spot. So let's measure, let's do these big ones here. Let's go E, G, A. How big are you? 120, I think that's 9.3. It's right in the middle of that, my point. And how about this one? G, H, C in that same position. Right, they're both in the top right corner. They are both, well, let me zoom in enough, or zoom out enough, I wonder. They're the same measure. They're the same measure. I could measure another pair of corresponding angles. Let's do the opposite side of it here, which will be the same thing because those are vertical, right? 129.8. There we go, 129.8. And on the other side, its corresponding angle is going to be in the bottom right of its group of 4 angles here. So DHF is 129.8. So corresponding angles are going to be congruent if the lines are parallel. Let's write that down. If the lines are parallel, the corresponding angles are congruent. Cool. Let's go investigate some alternate interior angles. All right, alternate interior. So there can be alternate opposite sides of this transversal and interior inside my 2 lines. So let's measure, we'll do AGH. That's 50.2 degrees. And how about GHD? That's also 50.2 degrees. You have to take my word for it. It really is, I promise. 50.2 degrees, and I put a random point I right there. They're going to be the same measure. Alternate interior angles are going to be congruent when the lines are parallel. So let's write that down. Alternate interior angles are also congruent. All right, let's go investigate some alternate exterior angles. All right, alternate exterior, alternate being opposite sides of this transversal. Exterior, we're going to be outside the lines this time. So let's look at angle EGB and its alternate. Man, why am I keep picking? Let's try the other side of G. Was that any better? I don't think it was. That was, how big is this angle? Well, we know it's the same as the vertical angle to it. 50.2 degrees. All right. So that guy out there, that's who we're looking at. 50.2 degrees. 50.2 degrees. And its alternate exterior angle, also 50.2 degrees. So alternate exterior angles are also congruent when the lines are parallel. Alternate exterior angles are congruent. So far we've got corresponding angles are congruent, alternate exterior angles are congruent, and alternate interior angles are congruent. The only thing now we need to investigate are same side interior angles. All right, some same side interior angles. So same side being same side of the transversal and interior being inside these 2 lines. So we'll do BGH. That's 129.8 and its same side is going to be right here. GHD, that is 50.2. Wait a second. Those aren't the same. What do I get when I add those up? What's 129.8 plus 50.2 equals 129.8 plus 50.2. Oh, that's 180. Ah, cool. So same side interior angles are supplementary if the lines are parallel. That's our last one. Same side interior angles are not congruent this time. They are supplementary. 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 If the lines are parallel, corresponding angles, alternate interior angles, alternate exterior angles, those will all be congruent. And same side interior angles are going to be supplementary. All right. We can use these facts to then prove that lines are parallel. If any of these things are true, then the lines must be parallel. I actually want to write that out explicitly. If any of those things are true, then the lines are parallel. So we'll say, if any of the following are true, then the lines are parallel. Exclamation point. It's very exciting. So what were those things? Corresponding angles. I'm going to abbreviate. Corresponding angles are congruent. If that's true, then the lines are parallel. Alternate interior angles are congruent. If that's true, then the lines are parallel. Alternate exterior angles are congruent. If that's true, then the lines are parallel. And finally, same side interior angles are not congruent. What are they? Supplementary. Supplementary. If any of these things are true, then the lines are parallel. All right, cool. You know what time it is? It's example time. We are going to try to see if we can show that some lines are parallel by showing that one of these four things is true. So let's go ahead and draw two lines. Gosh, they look parallel. Interesting. Draw a transversal. Okay. Let's say this angle here in the top left corner of this group of four, and this angle here in the bottom right corner of that group of four, those are congruent. And we'll say, are the lines parallel? Parallel. I'm using my parallel symbol. Well, is one of these things true? First of all, what kind of angle are these angles? They're not on the same side of this transversal, so they must be alternate. And they're on the outside of the two lines, so they must be exterior. They're alternate exterior angles, and by golly, they're congruent. That's what those markings mean. So yes, these lines are parallel. Yes, we have congruent alternate exterior angles. Alternate exterior with an E, there we go. Exterior angles are congruent. Check yes, that's correct. Let's do another one. Let's draw some more lines. Maybe we'll switch it up. Go this other direction. Wild. Draw another. So sorry, my video cut out for a minute. Alright. So we had two lines, and I drew a transversal, and I said these two angles now are going to be congruent. And my question is still, are these lines parallel? Are the lines parallel? That's what the symbol means. Well, are any of our four things true? First of all, who are these angles? Well, you're kind of in like the, I don't know, what would I call that area if I turn it this way? I could say you're in the top left of your group of four. You're also in the top left of your group of four, and those markings mean you're congruent, so you are corresponding angles that are congruent. Yes, sorry, my paper is just going everywhere. We have corresponding angles that are congruent, so yes, these lines are parallel. Yes, corresponding angles are congruent. So yes, we have lines that are parallel. Let's do another example. Example time. Come on, grab your friends. We'll go to very geometric lands. All right, draw two more lines. Bloop, boop, boop. And chop them with a transversal. Choppity chop chop. And let's say you are congruent to you. All right. Now, the question, of course, is, are those lines parallel? And we want to say, are any of the things that we said would make parallel lines, are any of them true? Are the lines parallel? Well, who the heck are you guys? You seem to be on the outside of these two lines, so you're exterior angles. But you're on the same side of the transversal. Same side exterior angles. Is that any of our choices? We've got same side interior. We have alternate exterior. Same side exterior angles. That doesn't do us any good. Nope. None of our 4 criteria are true. So these are not parallel lines. All right. Hot diggity, dog diggity. All right, next example. I've got 2 lines. I named them this time. I named them line M and line N. And I chopped them with a transversal T. And then I gave you some angle measures. This one right here is 2x plus 1 degrees. And this is 3x minus 5 degrees. And my question is, for what value of x are the lines parallel? For what value of x are the lines parallel? Parallel. I'm making my parallel symbol gigantic today. Okay, what value of x are these lines parallel? Well, who are these angles? They're on opposite sides of this transversal, so they must be alternate. And they are inside the 2 lines, so they are interior. So they are alternate interior. So if we want these lines to be parallel, the alternate interior angles must be congruent. Let's just say that. If the lines are parallel, the alternate interior angles must, far away T, be congruent. What does congruent mean? Have the same measure. These angles must be equal to each other. So let's set them equal to each other. 2x plus 1 needs to be equal to 3x minus 5 if these lines are going to be parallel, because they are alternate interiors. So let's do a little solvey, mathy. Subtract 2x on both sides to get 1 equals x minus 5. Add 5 on both sides and get 6 equals x equals 6. So if x is equal to 6, then the alternate interior angles are congruent, and therefore the lines are parallel. All right, last example. We've got 2 lines, A and B, and then a triangle in between them. And we've got an angle in the triangle here that's 60 degrees, an angle in the triangle here that's 60 degrees, another angle that's 60 degrees, and I'm saying, are these lines parallel? And we're saying, what? This doesn't look like what we just did. And I'm saying, sneakily, it does. We have 2 lines. And we have 2 different transversals, but let's just pick one of them. Hey, okay, got it. What? I don't know. I got a bunch of angles inside the lines. I got some angles that are on the same side of the transversal. We talked about same side interior angles. First of all, hold on. This angle here is 60 degrees. Right? This one here is 60 degrees. How big is this one? All the way across? Well, that's these 2 smaller ones added up. So that's 120 degrees. So this whole angle, which would be like, if I recopied this here, transversal, this would be 60 degrees, and this whole thing here is 120 degrees. Those are, what do we call these? Same side interior angles. And what was supposed to be true about same side interior angles if the lines were congruent? They were supposed to be supplementary. What's supplementary mean? Adds to 180. Do these add to 180? Let us check. 60 plus 120. What does that equal? Dun, da, da, 180. So yes, these lines are parallel because the same side interior angles are supplementary. Yes, the same side interior angles are supplementary. Et voilà! Très bien. Ça c'est tout. Let's do a recap of what we talked about today. We reviewed our transversal angle pairs. We had corresponding angles, alternate interior, alternate exterior, and same side interior. And then we said if the lines were parallel, some special things happen to these angle pairs. Namely, corresponding angles, alternate interior, alternate exterior, those are all congruent to each other if the lines are parallel. And same side interior angles, those are supplementary. Doop! The converse. If any of those things were true, then the lines were parallel. If we could show that any pair of corresponding angles are congruent, then the lines are parallel. Any pair of alternate interior, alternate exterior angles are congruent, then those lines are parallel. Or any pair of same side interior angles are supplementary, then those lines are parallel. All right, we did a couple examples. This one was alternate exterior angles. Those were congruent, so the lines were parallel. These were corresponding angles. Those were congruent, so the lines were parallel. These ones are just nonsensical angles. These are they are same side exterior angles, which is not one of our pairs. Not something we have information about. So no, those lines were not parallel. And then we had a little algebraic example. For what value of x were the lines parallel? Well, these were alternate interior angles, and if the lines are parallel, the alternate interior angles must be congruent, so we set them equal to each other and made them so, and solved. And finally, we used the fact that we had some same side interior angles that were supplementary to prove that lines A and B are parallel. Love you so much, scholars. Thanks for hanging in there. Keep on that hustle. I'll see you next time.